Hello and welcome to FAD Learning. In this video, we will explore the most important feature that has become stable in Angular 18 called signals. So by definition, what are signals? A signal is a wrapper around a value that notifies interested consumers when that value changes. And signals can contain any value, including primitive values or complex data structure like arrays or objects. This means that a signal is used as a wrapper for some type of functionality and is used to notify multiple consumers that a change has occurred. You can read signal's value by calling its getter function, which allow Angular to track where the signal is used. So let's understand the types of signals. There are two types of signals available in Angular, writable signals and computed signals. What is writable signals? A writable signal provides an API for updating its value directly, and we can create writable signals by calling a signal function with the signal's initial value. So here you can see that we can use signal as a type of variable and name of the variable is count. And we have to call or invoke the signal variable with round brackets like function. And to change the value of writable signal, we can either use the dot set method or the dot update operation to compute a new value from the previous one. But inside update function, we need to pass a callback function to update the value. Okay. Now let's move on to the second type of signal, which is computed signals. A computed signal is also known as read-only signal and it derives its value from other signals. So in this example, we can see that counter is a writable signal with the type writable signal and double counter is a read-only signal or computed signal with the type signal. And this computed signal depends on the writable signal, which is counter. And it means once the counter value changes, the double counter variable will also update its value according to the requirement using the computed function. Now let's try to understand these two types of signals with a practical example. So let me open Visual Studio Code and here I have created a component with name signals, and to render this component on web, I have imported the signals component inside imports array of app component and added the selector of signal component in the app.component.html file. Now let me close these two files and we will focus on signal component. So first let's understand writable signal. We can use a signal as a type of variable and we can create a signal just like a variable. The only difference is that we need to use the signal function and pass the initial value inside parentheses. Like here, I'll create one counter variable, counter equals to, I need to use signal which is imported from Angular/core and I need to pass the initial value inside parentheses. So I'll pass 0. Okay. We can also write this counter variable like this, counter of type writable signal of type number equals to signal. Here we'll pass initial value 0. So either you can write like this or you can write like this. Both are same. So I'll go with this. And as I said, it is similar to our normal variable like this. Like how we create a normal variable. For example, count equals to, we can assign value 0. So this is how we can create normal variable. But when we try to create a signal variable, we need to use signal keyword and we need to pass initial value inside parenthesis. And one more thing, we can also create an array using the signal by adding the array inside parenthesis with or without values. Similarly, we can create an object by adding open and close curly brackets with or without values. So it means we can create signal variable same like normal variable. And how to call the signal variable in HTML file? We can call signal variable in HTML file like function means with parentheses. So here if I want to call this, then I'll use string interpolation and I'll paste the counter variable. But additionally, we need to add the parenthesis. So this is the difference between normal variable and signal variable. So in order to call signal variable, we need to use parenthesis after the variable name. Okay, so let me restructure this quickly. Here I'll add text counter value. Now save the changes and we can see the output on the browser. Here you can see we have initialized the counter signal variable with 0, which is why we can see the counter value 0 on the browser. Now this counter variable is a writable signal, which means we can change the value of this counter variable. Okay. So as we discussed a few minutes ago, to change the value of writable signal, we can either use the dot set method or the dot update operation to compute a new value from the previous one. So here I'll create one constructor, and inside constructor I'll use dot set method to set another value for the counter variable. And how to access counter variable? By using this keyword, this dot counter dot set and then parenthesis. So here inside parenthesis we can pass the required value. So here I want to change the initial value of this counter variable from 0 to 5. Now save the changes and go back to browser, and now you can see the default counter value is 5. Okay, so this is how we can use dot set method to change the value of signal variable. Now we will see how to update the value of signal variable on click of button. So for that, I'll add a button called increment counter. And for this button, I'll add a click event with function on increment. Okay, now I need to declare this function inside TS file. And inside this function, I'll update the value of counter variable. So for that, again, I'll write this dot counter dot update. And here I need to use arrow function. So first what we need to do, we need to take initial value, and then for increment the initial value, I need to add 1 into this initial value. Okay, so this is how we have written the on increment function. Now, when I click on this increment counter button, you will notice that the counter value increments by 1. See, now the counter value is 6, 7, 8, 9, 10, like this. For every click, the counter value is incrementing by 1. This is how we can make use of update method to update the value of signal variable. Okay, I hope you understand how to use dot set and dot update method to update the signal variables. Now you might be thinking, what's the point of signals when we can achieve the same results with the regular variable? Why do we need signal? Okay, so let's understand this first. Why do we need signals? Angular 18 has introduced one more feature called zoneless change detection. And with this feature, we can say that Angular no longer needs the zone.js library. This means that without signals, Angular relies on change detection cycle to find out if some data has changed and then update the UI based on that change. If you remember, we have used rxjs subject and behavior subject to manage and share data in our applications. It works by notifying all consumer subscribers of any value changes with the help of zone.js library. But signals works similarly, capable of holding values of any data type, including numbers, objects, arrays, and more. With the signal feature, whenever you change any value, it notifies all consumers without the need for zone.js library. Let's look at this code to see the difference between behavior subject and signal. Both behavior subject and signal can hold initial value. This also holding initial value 0 and this also holding initial value 0. With behavior subject, if you want to manipulate data, you need to use pipe and map operator, which we need to import from rxjs library. This means we need to rely on rxjs library while working with behavior subject. But we can now do the same operation with signals. And while working with signal, we don't need to import rxjs or zone.js library. So here you can see that with the help of compute method, we can manipulate the data. This means signals offers an alternative to subject and behavior subject by removing the need of rxjs and zone.js libraries. So let's understand this with practical examples. First, let me disable the change detection by adding change detection property inside this @component decorator. change detection colon change detection strategy dot on push. By adding this line number 8, we can disable change detection in our application. Okay. Now I'll create a normal variable with name normal counter and I'll assign the value 0 to this normal counter. Okay. Now inside the constructor, let me comment out this function as well as this button as of now. And now inside this constructor, I'll add a set timeout function. Now inside this function, I'll change the value of normal counter variable to 50. Normal counter equals to 50. And I want to execute this function after 5 seconds. And additionally, I'll add one console.log to display the value of normal counter variable inside console. The value of normal counter. Okay, now save the changes and inside HTML file, instead of calling the counter signal, I'll call the normal counter. Let me comment out this counter. Now save the changes. What we did, we have added one set timeout function inside constructor and I have mapped this normal counter variable inside HTML file and I disabled the change detection strategy by adding change detection property inside this @component decorator. Okay. Now save the changes and open the browser. And here you can see the initial value of normal counter variable is 0. I'll refresh the page and after 5 seconds, this value should be 50. But as you can see here, after 5 seconds, the console logs the value 50, but the value of normal counter is not updating on the web. This is because we have disabled the change detection. One more time, I'll reload this page and you can see after 5 seconds, you will see the normal counter variable 50 inside the console, but the value will not get updated on the web. But the same value is not updating on the web. And this is because we have disabled change detection strategy. Let's see what happens if I enable this change detection. And we can enable this change detection by removing the change detection from this @component decorator. So as of now, I'll comment out this change detection. Let me refresh the browser again. 1, 2, 3, 4, 5. You can see the value. Inside console, normal counter value is 50 and we can see the same value in the browser. So it means normal variable depends on change detection in order to display the change on UI. But now I'll show this with a signal variable. I'll again disable this change detection. And as you remember, with normal variable, disabling change detection means we cannot render the updated value on the browser. But now we will see that with a signal variable, we can render the updated value on the browser. So for that here, instead of calling normal variable, I will call signal variable inside this set timeout function. And we can set the value of signal variable using dot set method. So here I'll set a different value that is 30 and I'll comment out this normal variable. And same here, I'll uncomment this signal variable and comment out this normal variable inside HTML file. Okay. Inside console, let me change this variable to counter. And now let me clear the console as well as let me refresh this. Now you can see after 5 seconds, you can see the updated value in the browser as well as console. So it means that a normal variable relies on change detection to update any changes, whereas a signal variable does not. So this is the biggest advantage of using signals in Angular. Additionally, by removing the need of zone.js library, we can increase our application performance. Okay. Now let's understand the effects function in Signal. What is effects in signals? Signals are useful because they notify interested consumers when they change. And an effect is an operation that runs whenever one or more signal values change. And we use the effect function to execute code whenever the value of a signal changes. For example, I want to execute some code whenever the value of counter signal changes. And we can achieve this by using effect function. But we don't use effect function to change the value of signal. Instead, we can use it to execute some extra logic whenever the value of signal changes. And we can use the effect function anywhere in the program, such as inside constructor or inside ng on init lifecycle hook. Here I'll create a effect function inside constructor. Let me comment out this set timeout function and let me uncomment this button. And here inside constructor, I'll write effect function, arrow function, then I'll log one message. Inside console.log, the value of counter is, I'll use counter variable. Here compulsory we need to use counter variable, this dot count. Okay. And effect we need to import from angular/core. So inside this effect function, I have used the counter signal. Now, whenever the counter value changes, this callback function passed to the effect function will be called and it will log this message in the console. Now save the changes and go back to browser. Let me clear this console. And once I click on this increment counter button, you can see the counter value is increments by 1. Along with that, we are getting message on console. The value of counter is 6. It means that every time the value of this counter signal changes, this callback function passed to the effect function is called. Now you can see if I click on this increment counter button, the value is increments by 1 and the respective message is logged on console. Now one more thing about the effect function is that we always need to specify the signal inside this function. For example, if you don't specify any signal inside the effect function like this, now save the changes. So in this case, we are not using any signal inside this effect function. So when this callback function will be called or on which signal change this callback function will be called is unclear. And the answer is it will never get called. So if you are not passing any signal inside this effect function, then this callback function will never get called. Now you can see on the browser. Let me clear this console. Here I click on increment counter button, but the message is not being logged because it's unclear to the effect function which signal change to execute on. But if we pass any signal here like this, now this callback function will be called every time the value of this counter signal changes. So basically the effect function allows you to define code that depends on a signal. So when to use computed function and when to use effect function? We use computed function to compute a value from a signal value, and we use effect function whenever we use to execute some code when the value of a signal changes. Okay, so hope you understand this effect function as well. And that's all about the basic understanding of signals. In upcoming videos, we will see more about signals. Thank you for watching and don't forget to like, share and subscribe to FED Learning for quick and easy learning. Thank you. Bye-bye.